Hey folks, welcome to your very first HL Physics extension video. So in this video, we are going to be talking about the electric potential of a point charge. So by the end of the video, you'll be able to determine the electric potential, at any point in space due to a point charge. So let's go ahead and get started. And what I'm going to do to start is define the electric potential. So in the past, we've talked about potential differences, which is going to be that difference between 2 points. However, we haven't talked about the electric potential, which is a little bit of a more general term. So the electric potential is the work done in bringing a unit of positive test charge, so one positive charge, from infinity to a given point. So what we're looking at is essentially if we are bringing a unit of positive test charge from zero, so as far away as possible, so a place with zero voltage, to whatever point in space near our charge that we're looking at, how much work do I have to do? So let's talk about the equation here. So we have our, we have our VE, which is going to be our electric potential. And that is going to equal KQ over R. So K is the same as it always is. 9 times 10 to the 9th. And I'm not going to put in all the units because, quite frankly, there are a lot of them, and we're not going to worry about them right now. Second, we're going to add in Q, which is going to be our charge in coulombs. And then finally, we have R, which is going to be the distance we are from our point charge. Now, one thing I would like to emphasize is that this equation really only works for a point charge. So if we're looking at, for example, a set of parallel plates, or if we're looking at a random line of charge, we're going to have a different situation. But this equation works for any tiny piece of charge sitting in empty space. So let's go ahead and use our equation to go ahead and solve a problem. So example 1.7.1, we are going to find the potential, the electric potential at point P, which is 0.1 meters away from a -6 coulomb charge. So let's go ahead and start by listing out our givens. So we know that the charge has a charge of Q equals -6 coulombs. And then we also know that R, our distance from P to our charge, is 0.1 meters. And that is all we know from the problem. So let's go ahead and list out our unknown. So in this situation, as I mentioned earlier, we're going to try to find our electric potential VE at point P. So that's going to be our unknown. So let's go ahead and go to our equation. So I know that VE is equal to KQ over R. So let's go ahead, so I can go ahead and I can plug in my numbers. So I'm going to go to my sub and solve stage. And I'm going to go ahead and put in my givens and my constants. So let's start with K, which is 9 times 10 to the 9th, times Q, which is -6, divided by R, 0.1. And when I stick that in a calculator, I get that my potential is 5.4 times 10 to the 11th. And my units here are going to be, as you probably expected, volts. So there you go, guys. We have just figured out the electric potential due to a point charge at a specific point in space. So our takeaways. First of all, the electric potential, V, is the work required to move a charge from infinity to a given point. Second, the electric potential for a point charge is given by the equation V equals KQ over R. So there you have it, folks. You are ready to figure out the electric potential for any point charge you might want.